Hi, my name is Lauren. I'll be doing section 14.4, problem number 6, and it was find an equation of the tangent plane to the given surface at the specified point, and our surface equation is z equals ln of x minus 2y at the point 3, 1, 0. And I went to GeoGebra and input the equation just because it kind of helps me to visualize like what I'm working with. And then this little pink dot is just the point that we were given because you couldn't really see it. Okay, so whenever we need to find an equation for the tangent plane at a specific point, we need to use z minus z naught equals the partial derivative of our surface equation with respect to x at the point x naught, y naught, multiplied by x minus x naught, plus the partial derivative of our surface equation with respect to y at the point x naught and y naught, multiplied by y minus y naught. So the first thing I'm going to do is take the partial derivative of our surface equation with respect to x. And if we remember differentiation rules from Calc 1, we know that when we take the derivative of an ln function, it's 1 over what's inside the parentheses and then multiplied by the derivative of whatever's inside the parentheses, and we'll be taking the derivative of what's inside the parentheses with respect to x, or the partial derivative with respect to x. And this will give us 1 over x minus 2y multiplied by 1 minus 0. And our 2y, it becomes 0 just because we treat it as a constant since we're differentiating with respect to x. And then this gives us 1 over x minus 2y. And then we take the points that we were initially given. So we evaluate this function at x equals 3 and y equals 1. And we plug those in, and we get 1 over 3 minus 2 equals 1. And then after that, we have to differentiate our surface equation with respect to y. Using the chain rule, I forgot to mention that we have to use the chain rule for this specific problem because it is an ln function. We'll get 1 over x minus 2y multiplied by the partial derivative with respect to y of what's inside the parentheses. And this will give us 1 over x minus 2y multiplied by 0 minus 2, which gives us negative 2 over x minus 2y. And then we do the same thing as we did in the previous equation. We plug in our initial points that we were given. So at x equals 3 and y equals 1. And we get negative 2 over 3 minus 2, which simplifies to negative 2. And then after we solve our partial derivatives, we can plug into our equation for the tangent plane. So we get, so at the point 3, 1, 0, our equation becomes z minus 0 equals the partial derivative of our surface equation with respect to x at the points 3, 1 multiplied by x minus 3 plus the partial derivative of our surface equation with respect to y at the points 3, 1 multiplied by y minus 1. And then we plug in because we had already previously solved for these two parts, so we can plug those in, and we'll get z equals 1 multiplied by x minus 3 plus, or we can go ahead and change that to negative 2 multiplied by y minus 1. And then from here, we basically just distribute our values and then we simplify our equation. So we'll get x minus 3 and then minus 2y plus 2, and then we simplify, and we'll get x minus 2y minus 1. And this is our final equation for the tangent plane of our surface. And then I also included these pictures from GeoGebra of what the tangent plane looks like graphed. Thank you.